In this video, what I want to do is introduce you to mean absolute deviation, which you will soon figure out is actually not a very complicated idea. So let's kind of break this apart and get an intuition for what it really means. First and most obviously, we know that mean in the context of statistics just means average, right? So this is average. Average. And secondly, right here, we see the words absolute deviation. And all this means in this case is the absolute value, right? Absolute value of how far a piece of data is from the mean of the data set. So we can just write average distance from mean. So mean absolute deviation, or most often abbreviated as MAD, is just the average distance of all the points of a data set from the mean of said set of numbers. Okay, now let's actually try to figure out what the mean absolute deviation of a data set is, and I've already written one right here. So our first step is to calculate the mean, which once again is just the average value of all the numbers. So if we were to add all of these numbers, I'll put a plus sign between all of them, and then divide all of these numbers by the amount of pieces of data in the set, which is 7, we would get 86. And I'll write this down here. We would get 86. Apologies. Mean is equal to 86. Now that we have our mean, the next step is going to be to calculate the absolute, keyword absolute here, distance from each data point to our mean. And there is sort of a formula for this. So it's going to be x1, and this just means, I'll write this one a little bit, x1. All this means is the first data point, right? And then we are going to subtract from this the average, which we denote by a little bar over x. And then we are going to add, the second, and then subtract from that the mean, and so on. And intuitively, it's important to remember that each of these expressions here are just going to be the absolute distance, right? So we have 85 minus the mean, and that, sorry, I should have written absolute value here. So this is going to be the absolute distance. So it's going to be absolute here. It's going to be the absolute distance from this point from the mean, right? So if we were to have 85 minus the mean, which is 86, and the absolute value of that is 1, and 85 is one step away from 86. Same thing for 87, right? This is going to be 87 minus 86, which is going to give us 1. And these are the absolute distance from each of these points from the mean. So now let's calculate the absolute deviation from these numbers from that mean. So like I mentioned, is going to be the absolute value of each of these points minus the mean. So this is going to be 85 minus 86 plus 87 minus 86 or plus 86 minus 86 plus 88 minus 86, and I'll write this down here as well, plus 84 minus 86 plus 85 minus 86 plus 86 minus 86. And let's see, this here is going to be, this is going to be 1, this is going to be 1, this is going to be 0, this is going to be 2, this is going to be 2, this is going to be, let's see, 1, and then this is going to be 0. So right here, the sum, the distance from each point is going to be 1 plus 1 is 2, 4, 6, 7. So we're going to have 7. But remember, we're finding the mean of these distances. So we're going to divide by the number of data entries in this data set once again, which is also 7. So our mean absolute deviation for this data set is going to be 7 over 7, which is equivalent to 1. So now let's kind of visualize what mean absolute deviation really represents using this number line here, and I've already taken the liberty of plotting all of these points. So we can see that the average value for a piece of data in this data set is going to be 86. It is going to be 86 right here. And the mean absolute deviation tells us that if we were to plot a point here and we didn't know the actual data set, we would expect the data point to either be 1 in the negative direction or 1 in the positive direction, once again because this is absolute. So as it turns out, mean absolute deviation is one of the most effective tools when it comes to determining how consistent or inconsistent a data set is, because it helps us understand how far each point deviates from the mean on average. It also lets us know if the mean of a set of numbers describes the value of the numbers in the set themselves well or not, because a low mean absolute deviation means all of the points are close to the mean, and a high mean absolute deviation means that all the points are spread out. So here we are given one more data set, and we are going to take another go at finding the mean absolute deviation of this set. Once again, the first step is going to be to calculate the mean, which we could do by summing up all of these values and then dividing by the number of values in this data set, which for this we would get 105. And then there are 7 points, and there are 7 pieces of data in this data set, which we would divide by 7, and we would get gives us 15. So the mean value of this data set, is going to be 15, and I'll write that right here. Mean is equal to 15. All right. Now let's subtract the mean from all of these data points and take the absolute value of that, which would give us the absolute value of the distance of each of these data points. So here we can see the absolute value of 10 minus 15 plus the absolute value of 5 minus 15, and so on. And I will go ahead and write all of these. Okay, now that I've written all of these, we can go ahead and simplify this. So this is going to be 10 minus 15 is negative 5, but remember this is the absolute value, so this is going to be 5. This is going to be 10. This is going to be 5. 5. This is going to be 0. This is going to be 15, This is 15. And this is 10. So if we were to sum up all of these, right, because we want to find the mean of the absolute distances, this would be 15, 20, 35, 50, and then 60. 60, and then once again there are 7 data points, so we're going to divide by 7. And let's see, I think this is as far as you can simplify the fraction, but the decimal would be, let's see, this would be, I think, 8.75. And there we go. We have once again calculated the mean absolute deviation of a dataset, and we are done.